Okay, YouTube, in this video we're going to continue to solve some oblique triangles using the law of sines, okay? And in this video we're going to focus on the side-side angle case, and this is the case that presents itself as sometimes ambiguous, which means you could have more than one triangle, you could have no triangles, you could have one exact triangle that make up this certain situation when you have two sides and some angle that follows it. Or you could think of it this way, you'll never forget this if you just spell that backwards, also an angle and then two following sides. So let's talk about what the ambiguous case is in the first place here. It says solve the triangle given that we have these measurements. So we're going to try to sketch this out. And so what I see is I have like a 40-degree angle here. And so you can imagine like this baseline here, but we have a 40-degree being formed with it. So 40 degrees is this A right here. And so we say this is A, angle A down here. And then if we were going to try to draw this as much as possible to scale, we'd say, okay, so we've got, A, in length is 54, and then B in length, I'm going to call this B down here. So lowercase b is 62 units, okay? So maybe 54. Okay? So we'd say that lowercase a is 54 degrees. The idea is that we have this triangle that in this situation, I suppose we'll call this C up here. We know that this angle A right here is 40 degrees, and then we have two sides following it. And in situations like this, you have to understand that there may be instances where I say this angle is restricted to being this, and I know this side right here next to it, and then the next side over from that, the angle side. But basically, what if we had a side length over here that was less in length than the side length right here, given this particular angle? So if we liken it to the situation that we see over here, we're saying that this is capital A, this is lowercase a, and this is lowercase b. And essentially what happens is you're going to get instances where if we were to imagine that this has an altitude being dropped from it, if I were to call this the height of this triangle, which we could actually solve for the height of this triangle, we could say that the sine of A is equal to h over b, but essentially h is going to be equal to b sine a. That being said, we know the length of h, and if a is less than h, and this is being opposite a longer side next to an acute angle, then what you get is a situation where this thing could like rotate all the way around here and never hit this side down at the bottom of the triangle. So if that's the case, if we were to say we have a situation like this where a is less than b, then you would have 0 triangles. Okay, it's not going to happen. You're going to want to know this, okay? So given some acute angle and then two sides next to it, if the further side is shorter in length than the adjacent to the angle side, then you have 0 triangles. Now, what if we were to say something like, we see over here, 54 looks pretty long. If we were to impose an altitude here, we could go solve for this h value, but it looks to me like A is not as long as B, okay? But it does look like it would be longer than the height. So in a situation like that, you can imagine that this over here being longer than the height, it could stretch down to here, or it could swivel and be on the other side right here, and you'd still have the same side length, but you'd have this new triangle over here that would just obey the same rules as what you had over here. It has the side lengths that you need and this given angle right here, which were the stipulations. So if it's the case that we could say that A is longer than B, okay, or sorry, longer than H, but it is less than B, and you can flip this around. But essentially you would have 2 triangles, and that's what we're going to look at here. We call this ambiguous because it could be more than one triangle, given the fact that you could have these 2 side lengths be what they are and still have this angle, given whether this swivels in or not. So that's what we're going to look at in this case. We say this 54. Just as a check here, I'm going to solve for h. We say that the sine of 40 degrees is equal to h over h over 62. And then we say, okay, so h would be 62 sine 40. Apologize for the handwriting there. So if I were to just, check this out, we say 62, we'll do this. We'll do the sine of 40 times 62. You'll notice that this side opposite here, this 54, is shorter than b, just like it was, like in that first situation where we said we had no triangles, except for it is also longer than h, 54, and this is not degrees here, but 54 is longer than this height value here, so I would have 2 triangles in this case. So we're going to look at using the law of sines to solve this triangle right here, and what I would want to do here is essentially, let's start with, do we have a side angle pair? We could organize our data, but we see that we have a side angle pair with our a's here, and let's say I want to solve for, angle B down here. Okay, So what we could do is we could solve for angle B. Knowing that, I'm going to put that on the top of this proportion, but we say sine of capital B down here, that's B right here, over 62 is equal to the sine of, now our side angle pair, we have 40 degrees and we have 54. And solving for this, we could say, well, then the sine of B, taking both sides times 62. We say sine of B is actually equal to, then, 62 times the sine of 40 degrees all over 54. And so we'll get a value for this. As a matter of fact, let me get my calculator here. So we're going to evaluate the top first. We have 40 degrees, the sine of that, times 62 equals, and then we're going to divide out what we get with 54, apparently, just 54. So we get this, 0.7380, 7380. So we get sine B is approximately 0.7380. And there's a reason why I'm only going out 4 decimal places. We're going to get an approximate value here. But we'll just take the sine inverse of both sides, and this should give us an angle. As long as we are in degrees mode, we'll get an angle in degrees. And so taking the sine inverse of this, and I can actually just do that now. We say second sine inverse, 47.5 degrees, 47.6. So we get that B is approximately 47.6 degrees. And we should go write this in on the triangle. So we say B is 47.6 degrees. Now here's the thing about this ambiguous case. We know that in this case, since this opposite side was shorter than B but also longer than this height right here, we could have two triangles. What you have to imagine is that we swivel this underneath and it kind of gives itself over to here. Okay. And so, and this is just not a very good sketch. But what I want everybody to understand is that this angle right here would be the same as this angle over here, this 47.6. And now in this triangle, we'd say, what is B? We'd be looking for this base angle right here. And the only thing I want to point out is that this 47.6 that could be conceived of as being on, the inside of this triangle, the outside of the triangle, has to add up with this inner angle right here to be 180. So the general practice is this. Once you find, the measure of angle B here, what we'll do is essentially this. We will go back and we'll say 180 minus that. I'm going to take 180 away from it and make it positive. You get your other situation where B could be 132. So we say B is also 132.4-ish, I think is what I saw. And we'll come back and do that situation here in a second. But I just want you guys to know that that's how you would solve for the other angle. Now, coming back over to here, I think we should actually write this out. We said A is 40 degrees. We have lowercase a was 54 units. We have lowercase b is 62 units. So we have b in this particular instance is 47.6. I do want to say this, then we could solve for c. We could say that if we were to take c minus these two angles here, so we have 180 minus those two angles, we say minus 47.6 minus 40. We get 92.4, so C is approximately 92.4 degrees. And then we could set up and do a law of sines to go solve for C down here. And actually, we could do that really quickly here. We would say that we have solving for lowercase c, put it on top. So C over sine of C, which we have now as a 92.4-ish degree thing. And then we say, okay, is equal to A, 54, over the sine of 40 up there. It's angle opposite. And so C is equal to 54 sine, if we write this out here, 92.4. When we take both sides of this times sine 92.4, and that's over the sine of 40 degrees. And we'll go ahead and solve for this right here, for a value at least. So we get, okay, 92.4, the sine of that, times 54, and we'll divide that by the sine of 40 here. And we get 83 point, about, I'd say 83.9. So 83.9, and this is in, units, 83.9. Is this reasonable when we look at all of these values and look at this triangle over here? Yeah, we say lowercase c would be about 83.9. That makes total sense. So now let's say in this other particular instance, we said, there'd be this instance here, where we have an angle and two sides, and it's swung back underneath. If you were to conceive of this triangle now, it looks like this. And we have the capital A, this is our capital C, this is our capital B. And not a very good sketch, but we could say that this is our 40 degrees right here. So we say 40 degrees. And we still knew that this is 62 and that this is 54. This is what we're essentially trying to understand now. We say now in this particular case, we were able to find that B, I want to list this out here, is explicitly equal to 180 degrees minus the 47.6 we found in the last case. Box that. That's what you want, because that's how we're getting this right here. We just took off this other angle B that we got over here because these would be the same. So that being said, then we could say that C, okay, we could go solve for C. It'd be this really sliver of an angle up here. And we say, okay, well, C would be 180 minus the initial 40 minus now the 132.4, and we get about 7.6. So capital C would be about 7.6 degrees in this particular case. It wouldn't be very big. And then you could go back and solve for lowercase c using the law of sines again. I'll leave that to the viewer. So that is the ambiguous case and how it affects you at times. Cheers.